So this section's on asymptotes, and we're going to be learning how to find vertical asymptotes and horizontal asymptotes. So let's look at vertical asymptotes first. Um, and so vertical asymptote has this definition. So the line x equals a is called a vertical asymptote if at least one of these statements is true. And basically, as x approaches whatever that is, from one direction or the other direction or both directions, if we're going to positive or negative infinity in any of those cases, then we have a vertical asymptote. So, for instance, if the limit as x approaches a is going to infinity, so a is whatever right here, so it kind of have vertical line there, and the graph would look something like that. And so from both sides, we're going to infinity, positive infinity. So the limit, the two-sided limit is infinite, or if it's going to negative infinity, so just flip this one upside down, then the limit would be negative infinity. Or it could just be that one side is going to infinity and the other side isn't. It's definitely possible to have something like this, and then maybe we have a hole there, and then maybe it just does something fairly normal there. So that would still be a vertical asymptote there, because as long as one side is infinite, it's a vertical asymptote. So you can imagine what the others would look like. So let's look at this example. We have the limit, and we're going to look at the limit as x approaches 3 from the positive side, and the limit as x approaches 3 from the negative side. The main thing probably to recognize first is when you plug in 3, I mean, that's always the first thing to do when you're evaluating limits. Just go ahead and plug in whatever x is approaching, because if it works, then you get an easy answer. But most of the time, it's not going to work. But so every once in a while, you get surprised. So if we just find f of 3, then we have 2 times 3 over 3 minus 3. And so that, of course, gives us 6 over 0. And so whenever you have a finite number over 0, you will have a vertical asymptote there. Now, you just have to figure out, is it going to be going to positive infinity or negative infinity? It's going to go to one or the other. And the easiest way to figure that out, if we're going from the positive side, and we have 2x over x minus 3, we are plugging in numbers for x. You could imagine this is what we're doing. We're plugging in numbers for x that are slightly bigger than 3. So think 3.01, 3.001, 3.0001, and on, just adding more zeros. So we get closer and closer to 3. So up here, we're obviously going to be approaching 6. Up here, we're approaching 0, but which way are we approaching 0 from? When you plug in a number bigger than 3 on the bottom, we get a positive number. It will always be positive, but it'll be getting closer and closer to 0 as we get closer and closer to 3. So this side is always, or the top is always positive. The bottom is always positive. We know it's going to be infinite because we get 6 over 0 if we just plug in 3. And so this will go to positive infinity on that side. So when we're approaching 3 from the right, from the positive side, the numerator is always positive because we're just plugging in positive numbers 2 times positive number is positive. And then the bottom is always going to be positive because x is going to be greater than 3. And so that will be positive, but it's going to be a small positive number. And so maybe we could be a little bit clearer. This is 6. This is going to be we'll write it like this for a small positive number. So that is going to go to positive infinity. Then on the other side, if we're coming from the negative side of 3, or the left side of 3, then what happens? Well, the numerator is still going to be 6. And we could write 6 because it is going to 6. But the denominator, now we're plugging in numbers that are smaller than 3, approaching 3. So we have numbers that are like 2.9, 2.99, 2.99999, however many nines you want to put. We're getting closer and closer to 3. So now this is going to be a small negative number. So it's going to be 0, but it's going to be approaching 0, but from the negative side. So every number that we plug in to evaluate, if we're looking at this incrementally, it from the left side of 3 is going to approach 6 on top and approach 0 from the negative side on the bottom. So this limit will be negative infinity. And so that's probably the easiest way to think about it. I mean, you could look at a graph also, but it's always a good idea when you're in a calculus class to be able to look at the function and not rely on the graph. That's kind of a big purpose of this class, is not relying on the graphs to find things out. All right, so next we have the definition of a horizontal asymptote. And horizontal asymptotes are always talking about when x is going to either positive infinity or negative infinity. And so if as the limit as x approaches infinity equals L, some finite number, then there is a horizontal asymptote at the line y equals L. And so we'll look at the graph on this one, and then we'll look at some functions without the graph. So this one, so find the limits at infinity and asymptotes. So we can see we have a vertical asymptote right there, so that is going through -1. We also have one here. And so we could say, so I have vertical asymptotes at x equals -1 and x equals 2. And if we want to talk about the limits, we could also do that. So the limit as x approaches -1 from the left is going up to positive infinity. Oops, not plus or minus, just plus infinity. The limit as x approaches -1 from the right is going to also be positive infinity. But if we look at as x approaches 2 from the left, now we're going down to negative infinity. And as x approaches 2 from the right, we're going up to positive infinity. And so in this case, the limit as x approaches -1, you look at the two-sided limit, will be positive infinity. The two-sided limit as x approaches 2 will be non-existent. It does not exist because we don't go to the same spot. But we still have vertical asymptote at 2 and -1. All right, and then we notice as we go out to negative infinity, the graph is coming in right there. And always assume, of course, that whatever the picture is showing you, that's nothing interesting is going to happen after that. It's just going to keep doing the same thing. So as we go out, we are getting closer and closer to 2. So horizontal asymptote is y equals 2, and then going out this way is y equals 4. And we can also talk about this in terms of limits. So the limit as x approaches negative infinity of f of x is 2. So going out this way. And then the limit as x approaches positive infinity is going to be 4 for the other asymptote. All right. And so when we look at the function in a minute, not the graph, but the function, this is how we decide where the horizontal asymptotes are. And we don't need the graph. We can just evaluate the limit as x goes to plus or minus infinity, and that will tell us where the asymptotes are. All right, so let's look at 2 more examples. And as long as we're talking about rational functions. So these are rational functions with polynomials. Um, these are pretty straightforward. It can get tricky when you start looking at absolute values or square roots or things like that that are a little bit can be a little bit trickier when we're going out to infinity. But these are pretty straightforward. And you don't have to consider too much. In fact, you kind of probably learned these in an algebra class or pre-calc. You may not have called them limits, but anytime you found a horizontal asymptote, that is what you were doing, and you had shortcuts to doing that. We're going to do it the proper way, I guess, the more calculus way, and the way that is safe to do when you have functions that are not polynomials on top and bottom. So if you have a non-polynomial function, you have to be a little bit more careful. So we'll do it that way. So when we have this, pick the whatever. So in this case, the degrees are the same on top and bottom. But if they were different, you'd pick whichever one is biggest. So if this was an x cubed, then we'd choose x cubed. Or if this was x to the fourth, we'd choose x to the fourth. So it is whatever is biggest. So in this case, they're both degree 2. So what we're going to do is we're going to divide these by x squared. So we're going to divide the top by x squared, and we're going to divide the bottom by x squared, which doesn't change the function, but it is going to let us see what happens as we go to infinity. And so we'll just divide, and you can write this, I guess, at 3x squared over x squared minus x over x squared minus 2 over x squared. We won't do that. We'll skip that little step, but we're still going to do it. So now simplify this. So 3x squared over x squared is going to be 3. X over x squared is 1 over x. So that'll be minus 1 over x, and then minus 2 over x squared. And then do the same thing on the bottom. 5x squared over x squared is 5. 4x over x squared is plus 4 over x, and then 1 over x squared. All right, so now, and I guess we should have said this at the beginning. If you plug in infinity, what do you get? Because like I said on the first example, you should always just plug in what x is approaching and see if it works. And so, which rarely works when it's infinite. But if you do, you get infinity minus 2. You cannot do infinity minus infinity. That is not 0. That is not necessarily infinite. So you cannot evaluate infinity minus infinity. And then on the bottom, we also get infinity. So infinity over infinity is not something that we can evaluate. So we are fixing this so that we're writing it in a different way so that we can evaluate it. So now if we look at the limit as x approaches infinity of the rewritten function, now plug in infinity, and what happens? All 4 of these terms that have an x on the bottom will go to 0. So that will go to 0, that will go to 0, that will go to 0, and that will go to 0, and we are left with just 3/5, because the limit as x approaches infinity of 3 is 3, the limit as x approaches infinity of 5 is 5. So this one just goes to 3/5. All right, let's look at the next one. And same idea, we are going to pick the highest exponent and divide each term in this rational function by that exponent. So, and we'll write the limits in as we go. So x squared plus x over x squared. And then on the bottom, we have 3 minus x over x squared. All right, so now do the simplification. So we have limit as x approaches infinity. X squared over x squared is just going to be 1. And then x over x squared is just going to be 1 over x. And 3 over x squared. And then minus 1 over x. All right, so just like last time, um, anything with an X on the bottom is going to go to zero. So zero, that goes to zero, that goes to zero, and then this is just one. So what are we left with? We are left with 1 over 0. Now, that tells us that the answer is either going to be positive infinity or negative infinity. And it matters, well, it is completely dependent on what this one is. So the numerator is positive no matter what. Um, and we can see that from the original, because infinity squared is infinity, plus another infinity would be infinity. So infinity plus infinity is definitely infinity. If you subtract infinities, we don't know. If you divide infinities, we don't know. But if you add or multiply positive infinity, you're still gonna have infinity. So the numerator is positive. What about the denominator? So the denominator, and you can look at the original part, or you can look at this part. Obviously, it's going to be easier to look at this part. So imagine we are plugging in big numbers for x. So we have 3 minus some huge number. That is clearly going to be negative. So the denominator is always going to be negative. The numerator is always positive, and the numerator, basically what's happening here is with this having an x squared, this this having an x squared, and this having a lower degree polynomial, the numerator is going to be growing much, much, much faster once x gets big enough. The numerator will be growing faster than the denominator. So this is a positive number, a very small negative number, and so that is going to go to negative infinity. So so in this section, you have to think a little bit abstractly. It's not super abstract, but you have to kind of imagine what is happening when we get bigger numbers in for x, and or plug in, like the first example, um, plug in something that makes this approach zero. Are you approaching from the negative side or the positive side? And so you got to get used to thinking like that. So, all right, so that'll be it for this video.